Mr. Lee. Welcome to part 2 of the video on algebraic identities. So this video focuses more on factorization, and that is where we write the sum a squared plus 2ab plus b squared as a perfect square, a plus b. We write a squared minus 2ab plus b squared as another perfect square of a minus b squared. Last but not least, the difference of the squares can be factorized out as a plus b times a minus b. So we try to write them as products of terms this way. The difficulty in the factorization part is to recognize first and foremost that the terms can be written as a squared and b squared, and the middle term can be written as 2ab. Okay, that is for the first and second result. So let's just use part A to illustrate what I mean. So in this case, 9x squared minus 12x plus 4, you need to factorize this completely. The first thing that we observe over here is that there are two perfect squares, namely 9x squared, and that is your 3x squared. And the last term, right, 4 is a perfect square, which is 2 squared. So onus is on you to check whether the middle guy, the 12x, can be written in the form 2ab or not. So in this case, let's verify. This is 3x squared. This is 2 squared. The minus sign remains there. And let's just check 12, right? 12x is basically 2 times of 3x times 2. So indeed, this format does work well over here. And once we can verify that it does work, right, this just factorizes out as 3x minus 2 squared. Right, this is your a minus b squared. Likewise, for part B, right, you now have a difference of terms, in which case you find that these are perfect squares again. Right, this is actually 6y squared. This is actually 5z squared. So as a difference between two squares, this again can be factorized out as a plus b multiplied by a minus b. Okay, seems quite easy so far. Okay, part C, right, you have 81a power of 4 minus 1. So although this is not a direct square, but you notice that here 81a4 can be written as 9a squared squared. Okay, 1 trivially is 1 squared. So again, this can be seen as a difference of two squares, which you can use the result of a plus b and a minus b. Well, but as you do so, you find that you can actually factorize the second guy one more time, because the second guy is in the form 3a squared, again minus 1 squared. So this is yet another type of a plus b, a squared minus b squared. So that allows us to factorize this further as 9a squared plus 1. The first time we keep. The second guy, right, now becomes a plus b, a minus b. So you do this factorization until you find that you can't factorize this anymore. Right, so the three terms over here, right, 9a squared plus 1, 3a plus 1, and 3a minus 1, it seems that there's no way you can factorize it, at least based on what we have seen so far. So we stop here for part C. Okay, part D looks a bit complicated, but again, right, this is still a difference between two squares. So 9x plus 1 squared, right, before you even expand out everything, you realize that this can be written as 3x plus 1, the entire thing squared. Whereas 16x minus 1 squared can be written as 4 times of x minus 1 whole thing squared. So again, we are in our favorite difference between two squares over here. So this becomes a plus b. The only thing over here is that this term looks more complicated than usual, but nonetheless, the properties, the form still remains the same. Right, the second one is a minus b. Okay, so just simplify each of the square parentheses along the way. You see that the first bracket gives you 7x minus 1. The second one gives you negative x, I believe, plus 7. Okay, so this is completely factorized nicely. Okay, last but not least, part 5, part E. Part E, you find that there's actually 4 terms, contrary to the forms that we've been seeing. But, well, 3 of them involves at least y. So let's see whether we can do something about that over here first. So I first take out a negative sign from the last 3 terms. That gives us y squared minus 6y plus 9. Again, just by observation, right, this is of course a squared. This is of course b squared. This can be verified to be minus 2ab. So if you can see that, right, the second term would have factorized as minus y minus 3 squared. And now this becomes a difference between two terms. They are squared. Right, 25 squared is just 5x whole squared. So with that, we can actually write it as a plus b and a minus b. Okay, so this simplifies to 5x plus y minus 3 and 5x minus y plus 3. And that's it for the factorization. Okay, so these are just some examples where you can use these free results to help us. Hope you find our videos useful, and well, see you in our next video.